Good afternoon, TechNation. Thank you all for participating in today's webinar. We're thrilled with the great turnout today with over 680 attendees pre-registered. A few notes before we begin. During today's webinar, all lines will be muted, but you can submit questions during the presentation by using the questions feature on the dashboard on the right-hand side of your screen. If you are having difficulty, please email us at webinar@mdpublishing.com. Your participation today is eligible for 0.1 CE credits with the ICC. You can obtain your certificate of attendance by completing the post-webinar survey at the conclusion of today's webinar. This survey will appear immediately on your computer screen following the conclusion of the webinar. Certificates will be emailed on or before April 1st. If you do not receive your survey, please email us at webinar@mdpublishing.com. TechNation would like to thank our sponsor for today's webinar, Global Medical Imaging. GMI sells, services, and supports ultrasound systems, nuclear cameras, and PACS networks across the USA. GMI focuses on one thing, transparency. They serve their customers with confidence, knowing that they can provide the best experience in the industry. From sales to service and world-class support, GMI has the products and services you need to support your business today and grow tomorrow. Call GMI today to learn how they can help with your business, or visit GMI3.com to learn more. Our presenter today is Pat Lynch, an experienced biomedical manager with formal training as a technician, engineer, and in business management at the graduate level. He has worked exclusively in healthcare since 1975 and has managed clinical engineering and biomedical departments since 1979. Pat, you may begin your presentation whenever you're ready.
Thank you very much. Hey, welcome everybody. I'm certainly glad to be here today and glad to share this information with you. First of all, for those of you who may not know, I want to briefly tell you explain to you who I am. First of all, I'm a CBET, been that since 1979, certified clinical engineer, been in biomed for about 40 years, managed a large in-house program, an ISO, and corporate biomeds. I've been active in the certification of BMETs and clinical engineers, and I've been very active in a lot of biomedical associations across the country. Most recently, we've started a brand new one for the state of Georgia that is growing by leaps and bounds, already has 80-something members. I do write monthly articles for TechNation and BINT, the Amy magazine, and I currently work for GMI in sales development, but I don't do anything relative to the operations of the company. GMI pays me to go around the country and be a chief do-gooder, basically do good things for the biomed community, and they're willing to pay for that because it gives them a little good press and it gives back to the profession. Well, extension cords, they're a problem, and unfortunately not everybody knows how to use them or be safe around electricity. This is a picture of a very, very old hospital operating room. You'll see that there is absolutely nothing electrical in the room except for this infusion, this suction pump back in the corner here. Everything else is pneumatic. There's no electricity, no plugs, so we didn't have any problems with extension cords. Here's a modern operating room. They've got at least 10 overhead booms, and there's no cords anywhere. Of course, it hasn't been fully staged and all the equipment there, but you'll look at the number of outlets on each of the booms. They're made to accompany all of that electrical equipment. This is a more typical operating room. I know you probably noticed the unsecured tanks there, but you'll notice cords all over the place, tripping hazards, hard to get around, just not a good environment to work in, not a safe environment. You might wonder why I got involved in this, and this is actually a problem that I solved about 12 years ago. I was at a hospital that I managed in Atlanta, and I went to labor and delivery room, and I saw an anesthesia machine that was within about 3 feet of an electrical outlet, but I saw a tremendous amount of electrical cords curled up behind it. I thought that was pretty strange since it was within 3 feet of the electrical outlet it was plugged into, so I measured the length of the cable, and if anybody would like to guess, I would like you to write down the number of feet of electrical cord that went from that wall to the anesthesia machine. Granted, the anesthesia machine was 3 feet away. Well, I'll give you the answer. It was 67 feet of electrical cord. There were adapters, there were octopus, there were multiple outlet strips, there were extension cords, there was every manner of device hooked up, and 67 feet of electrical cable to go 3 feet. Well, that's when we realized there was a problem and we needed to look around and be vigilant and do away with these issues that got out of hand. And we figured out a way, and that's what I'm going to share with you today, a very successful program that applies directly to CMS. The problem, we've always had a problem with extension cords. They've always been disallowed in hospitals for permanent installations, and permanent means for longer than 90 days. That's always been the key. The problem is that these multiple outlet strips were not technically considered extension cords, so they got put into use, and nobody was ever assigned responsibility for them. They were just put in. Nobody tests them regularly, and there are many low-quality relocatable power taps that come from Walmart, the local office supply, anywhere else. And these things are not hospital grade. Who knows where they're made? Who knows what kind of quality control there is? Who knows if they're made soundly? Who knows if they're wired correctly? Nobody ever tests them. There's no incoming inspection ever done to make sure that they're even wired properly or that the grounds are intact. And because of all the chargers, personal equipment, Game Boy, video games, and everything everybody brings into the hospital, hair dryers and curlers and all that sort of thing, there ends up being a mix of non-patient care and patient care equipment. And it's this non-patient care equipment that might trip a breaker or increase a leakage current to the medical equipment and cause a problem for the patient. CMS's reaction, and I've got the flip-flops in here because they've definitely flip-flopped on this one. First of all, they said, well, we're just going to ban them. Get rid of them. You can't use them. They're absolutely not allowed to be used at all. Well, everybody raised Cain about that, and then they came back and says, well, not really. We didn't really know what we were talking about, but here's what you really need to do. And they said, now, just no power outlets, no extension cords, and that there's a certain set of criteria upon which they will, and that is the waiver that they announced lately. The real problem with outlet strips are, and there's a multitude. First of all, they can be daisy chained. You hook one to another, and you end up with this long link of outlets, and I don't blame the users, because when you need outlets, you have to plug it in. The problem is that each one of these probably has a circuit breaker on it, and the very first one that is plugged directly into the electrical outlet is drawing all of the current for all of the outlet strips, and it's likely to throw the breaker. You can overload them very easy just by having so many things plugged in. They end up getting tied in knots. They're not UL tested. The plug is hanging out of the receptacle because they're not good quality plugs. The device is hot to the touch. We've all felt this, and that's where a cord gets internally broken, and there's high resistance, and the cord actually gets hot. Melted, frayed, or discolored wires. There's nobody looking at these things, so they can be They're usually laying on the floor. People walk on them, step on them, put the legs of tables on them, just tear them up in all sorts of ways, and there's nobody who's assigned to be vigilant over them to correct them when there is a problem. And they do use them as permanent wiring. We all know once they're in forever. Nobody ever takes them out. The reason you put them in does not go away, so they leave them there. And obviously you can have ground pin missing and an ungrounded situation simply because nobody's testing it. The real problem here, the real problem that we need to work on here is that there are short power cords that will not reach an available outlet. Power cords on medical devices typically are 6 to 8 feet long, sometimes 10 feet. And if you will look around in most areas that have a lot of electrical equipment, there are adequate outlets in the room. There just aren't any within the reach of where that cord is going to reach. You walk into an operating room where there are multi-outlet strips and you know, all manner of expanders to expand the number of outlets, and you will find extra outlets, but they're on the side of the room, on the opposite side of the room. They're by the doorway to the hall. So the problem, one of the problems is in most areas of the hospital, we actually have enough outlets. We just don't have power cords that'll reach them. In operating rooms, there is a special problem, and that is that the operating room table sits in the middle of the room, and there has to be 360-degree access around it. And these operating tables are electrical, so the cord has to get to an outlet somewhere. In operating rooms, we don't like to put them in the floor because they hose down the rooms to clean it and they can get wet. We can't put them on suspended ceiling connectors for the most part because it kind of gets in the way of the sterile field. So what we need to do is we need to figure out this real problem. There definitely are too few wall outlets in some areas. And we all know that the quantity of medical devices has multiplied. When I first got into the profession or was in a hospital, I took care of 25 operating rooms. And in all 25 of those operating rooms, and 3 of them were open heart rooms, in the grand total of that thing, I had right about 500 pieces of equipment to maintain. Well, anybody today counts the number of equipment in your operating rooms. 25 operating rooms is going to have at least 2,000 to 3,000 pieces of equipment. The other problem that I've witnessed is that they often rearrange areas. When you build, for example, an operating room, and I keep coming back to that because it's the most equipment-intensive place in the hospital, they tend to identify where the head wall or where the head of the patient is going to be, and they put lots and lots of outlets around there for the equipment to plug into. Well, then they decide to rearrange the room. They move the head to a different wall, and all of a sudden there aren't outlets there that are needed. The other problem is maintenance departments make really poor outlets. They use electrical boxes that have holes in them. They're not watertight. They don't have proper strain relief. It's interesting, this little guy down in the bottom corner, I actually bought him at a Walmart type store in Guatemala City. This is, I guess they decided to make multiple outlet strips, you know, cutesy. So this is some kind of little reindeer looking guy. The other problem is sometimes there are different kinds of electrical outlets. Not so much these days, but in the old days, you would have twist locks, you would have the Hubble, the twist locks, the explosion proof, all different ones, so you end up having to have adapters to adapt from one type of plug to a straight blade plug. This is probably the worst case I've ever seen. This is an actual case where somebody needed to make something. They didn't have a box, so they said, hey, A detergent bottle is pretty waterproof. We'll put it in there and tape it up, and it should be better than nothing. Everybody does overlook outlet strips and extension cords. They're just one of those unseen things that's always around that nobody pays attention to. We all know that facilities, the maintenance department, they've got a requirement to check all the electrical outlets in the hospital once a year. So they very diligently go around with their tester and their tension tester, and they unplug something from the wall and they plug in their little tester and test the outlet. And once they've tested and determined the outlet is okay, they plug the plug back in without paying any attention to what it was. It could be a piece of patient care equipment, it could be a television, it could be a multi-outlet strip or RPT. Biomed, bless our heart, we go around and test the equipment. So we take the equipment, we follow the power cord down to the end of it, and we unplug it from whatever it's plugged into, even if it happens to be a multiple outlet strip of some kind. And we test it, and then we very diligently plug it back into wherever it was plugged in before. So everybody who's charged with surveillance of the electrical system and equipment overlooks these items. Nobody inventories, tests, or documents anything regarding RPTs or extension cords. We all know that too many items can be plugged into one outlet strip, and they can trip breakers. Patients use hair dryers and other things that they plug in that draw a lot of electricity that can just put it over the edge, trip a breaker, and then you've lost your power to the entire, any patient care equipment that's plugged in. And we know today that if you have something, for example, that's digital, it's not going to come right back on. It's going to cut off, and you've got to then come in and manually turn it back on, wait for it to boot up and all of that. And also these other pieces of equipment that may be grounded, may be ungrounded, or can affect leakage current for the equipment. CMS finally did give us a categorical waiver to allow for the use of power strips if you meet all these life safety code requirements. So the place to look is Life Safety Code 2012, the 2012 edition, for the power strip requirements. I'm going to summarize them here. It basically says you can use them to power cart-mounted, pedestal-mounted, table-mounted, or rack-mounted equipment if you meet all of these conditions below. The first one, they have to be permanently attached to the equipment assembly, which, based on this waiver, actually means it can be attached to an IV pole. It works just as well. You need to check and make sure that everything plugged into this power strip does not exceed 75% of the current carrying capability of the flexible cord. I've actually extended this to say if it has a circuit breaker, don't let it exceed 75% of the ampacity of the circuit breaker, because in almost all cases the circuit breaker is rated at a lower amperage than the power cord is itself. So I go with 75. If it's got a 15 amp breaker, you take 3/4 of that, so you say about 12 amps is all the current that should be drawn through this unit. And the waiver also states that you have to have an ongoing maintenance program that regularly verifies and documents your testing of this. And that is electrical and mechanical integrity, which is strain reliefs, ground pins, tension of the outlets themselves, proper polarity, all that. And this is a key one, you have to employ some sort of means if you've got unused outlets to make sure that you can't plug anything else in. Because you know darn well that a patient, if she's got a hair dryer and she sees an extra outlet, she's going to plug it in. and then it may take a safe unit and make it unsafe. So you have to plug the unused outlets after you test it. One of the waiver conditions that they added was that they first said that the power strips or RPTs had to be installed by the manufacturer of the equipment as a part of that equipment, but that you or I could not come along after the fact and add an RPT to a piece of equipment. Well, that proved not to be feasible, so they have modified that a little bit. And they say that here's where it says power strips can be attached by qualified personnel. I would assume that to be either an electrician or us. And for precautions, you need to, it says that you also need to pay attention to these additional precautions that deal with ground fault and overcurrent protection, preventing cords from being tripping hazards, making sure that everything is properly connected so that you don't have tension on the wires. You have to have strain reliefs on them. And you can't daisy chain them. And you can't overload them with high-load devices. So now Underwriters Laboratories has come out with a special statement. It's called UL 1363A, which is something called a special purpose relocatable power tap, SPRPT. There's only a couple of companies that make these things. I'll tell you about them in a minute. And we'll go over some of those criteria. But here's the action plan. Here's how you actually do it. We're down to the meat and potatoes now. Here's how you fix your hospital. And this works in any hospital. First of all, most pieces of patient care equipment are provided with 6 to 10 foot power cords. My recommendation to you is to go out, buy a bunch, I mean maybe up to 1,000 or 2,000 long, 20 foot power cords with a detachable plug on the end. There's a lot of companies that sell these things. They'll make you custom ones. They'll make them hospital grade. They'll do whatever you want to them. You go and buy a bunch of these things. Because of the extra length, you may want to increase the wire gauge to either 16 or 14 gauge to make sure that you don't have any amperage capacity issues. And then you sweep through the hospital. You have your technicians go through every department one by one and remove every single short power cord and plug in a long power cord. You do this to virtually every piece of equipment in the hospital, except equipment that you know is permanently situated beside an outlet and will never need a cord that long. But the majority of your equipment and virtually everything in an operating room needs to be changed to these longer cords. Okay? So when you do this, you will be able to eliminate as many as 80% of your power strips. Because once you put these longer cords in, they will be long enough to reach to the next outlet. We've done this in a hospital, a large hospital, and it worked great. And it did get rid of almost all of the RPTs or outlet strips that we needed, that we had in use. We did have boxes and boxes and boxes of power cords, no doubt about it. Step 2, after you do this, and this may cost you $6,000 to $8,000 to $10,000 to do this through a hospital, even a decent sized hospital, and it may take you as many as maybe 20 man-hours worth of work to do this. You send 4 technicians to sweep the hospital, and they spend 5 hours going through, their portion of the hospital or their floor of the hospital, and you change everything. Not that big a deal. Now, the second step is you're going to have some pieces of equipment that have hardwired power cords. They're going to be things that do not have detachable power cords, but you still need to make their power cords long so that they will reach an available outlet somewhere in the area. What we did 12 years ago was we actually went in, took off the strain relief, went inside the unit, disconnected the wires, bought some bulk wire, wired a new power cord, put a plug on the end, and made a long power cord that was still integral to the unit. That took a long time. We figured out a better way to do it. Go out and buy you some male and female twist lock plugs. Twist lock, they're 3-wire plugs, but they twist and lock together so that you can't pull them out. Now, the step 2, you take it and you go to your piece of equipment like a video cart or an OR table or an exam table, and you cut off the existing power cord about 6 inches from the machine. Then you install a male twist lock to the equipment, to the cord that goes into the machine. So now you've got an operating room table sitting there with a 6-inch cord and a male twist lock out there. Step 4, you go and make a new power cord 15 to 20 feet long with a straight blade male plug on one end to go into the wall and a female twist lock to connect to that little 6-inch power cord that's coming out of the piece of equipment. You can order these pre-made. No question about it. You don't have to make them yourself, but you can. So then what you have is you actually have a longer power cord with an extra connector in the middle of it. You've not had to go inside the machine to make the time-consuming changes, and you haven't really modified anything. You've made a longer power cord. There's absolutely no rules or regulations or stipulation that says that you cannot take a cord, cut it in half, and put a twist lock pair of connectors in the middle of it. So you do that for every single one of your operating room tables, your video carts, your exam tables, and your items that have permanently wired cords in them. Here's what it looks like. You have a piece of medical equipment up at the top here. You have a 6 to 10 foot original power cord here. You need to put a 20-foot cord on it, so instead of going into the piece of equipment, you add a male and female twist lock connector in line 6 inches from the unit, and then the one going to the wall to make it a 15, 20, 50, 100 foot, whatever you need. You make it, you do it, you put it in. And here's what the twist lock looks like. You can buy them very easily at Lowe's, no problem whatsoever, but you do not have an extension cord, and you only have a modified power cord. This is about 20 minutes worth of time. Not a real big deal. Now, where you legitimately have to install RPTs, and there are some areas where you just do not have enough outlets in the area. I only know right now of 2 companies that make them. AIV out of Baltimore, Maryland, and Triplite both make certified RPTs that are allowable by CMS and anyone else to meet this purpose. They lock in place, they have all the bells and whistles that you have to have, and they're totally certified for these purposes. And they have long power cords. You can get these things with 15 to 18 to 20 foot power cords on them. Here's a key thing. Once you put an RPT in place, and you will have to buy enough of these to go out and replace any multiple outlet strips that are being used around patient care equipment, you got to do a couple things when you put them in service. Number one, you have to inventory them. Remember the rule back there says you have to have an ongoing maintenance program. The only way to have an ongoing maintenance program is to inventory them and treat them like any other piece of patient care equipment. And I've long maintained that a multiple outlet strip, or RPT, is nothing more than a very simple piece of medical equipment. It's a piece of equipment that has a cord, it has a male plug, and it has several female receptacles in it, and it may have a circuit breaker. Other than that, it's a very simple item. Inventory it, surveil it, look after it, test it, document it, boom, you're set. You can risk rank them. You can look at your risk, apply the same risk criteria that you would use for any other piece of patient care equipment in the hospital, but I suspect that you're going to need to test them at least once per year, and that includes the electrical integrity of the power and the ground, as well as the mechanical integrity of the tension of the outlets. And then put them on your PM schedule and test them when you test everything else. Extra steps for these special RPTs. Once you plug in all your pieces of equipment that you intend to plug into this thing, you have to make sure that the item does not draw more than 75 or 80%, I've seen conflicting numbers, of the amperage capability of the RPT or the special RPT. So look at the circuit breaker. If it's 15 amps, you need to be able to measure the current draw of all your items plugged into it and make sure that it's not over 80% of that. So you plug in, and then you have to plug up all of the unused outlets to make sure people don't come up and plug in unused equipment and exceed that 80% capacity. You see these little plugs down at the bottom? These happen to be made by Triplite. You can either go out and purchase some child-proof connectors from the, from Walmart or Babies R Us or something and plug in there, but people can take those out. I particularly like the Triplite because they expand. They have you can look, where is this thing? You can look right down here and see that there is a little outlet. There's a little Phillips, which when you plug this thing in, you push it in and it expands, and it will not allow it to come out unless you have a Phillips screwdriver to be able to take it out, so it protects it from the average nurse being able to get into it and plug other stuff in. The other thing you have to do is you have to make sure that you're not plugging in high current equipment to a multiple outlet strip because they don't have the current carrying capability. They need to be plugged directly into the wall and not sharing their electricity with anybody else. This is an example of a cord of an engraved sign that we had made, and they're probably still all over the hospital down in Atlanta. And they're made of plastic, they're engraved. We actually tie wrap them to the electrical cord up near the power plug, and it basically instructed the users that this unit has to be plugged into a wall outlet, and you weren't allowed to plug it into an outlet strip. We use this not only for ventilators, anesthesia machines, we used it for lasers, we used it for ESUs. We would not allow those units to be used on a multiple outlet strip and required them to go straight to the wall. Here is very quickly how you measure the current draw in an SRPT. You buy one of these units, which is a line splitter, and the line splitter, if you put a clamp-on ammeter around a power cord, you're putting it around two wires, and the amperage, the electrical fields going through that cancel out, so you always read 0. So what you have to do is you have to split the wires, the black and the hot and the neutral wire, so that your clamp-on ammeter only goes around one of them, and then it can measure the current accurately through that one. So you buy this little device for about, I don't know, 20, 25 bucks at Lowe's or somewhere, and you plug your special RPT through it, plug it into the wall, put your clamp-on ammeter on it, and then you have to turn on all of your equipment and make sure that it is operating totally, you measure the current and make sure that you're not exceeding your amperage. It's a very easy way to do. You got to buy a couple of pieces of equipment. It's not hard to do, but you need to do that for every single situation where you have equipment plugged in to an SRPT. There's another good reason to have as few SRPTs as possible. Get the long power cords. You're going to eliminate the need for those things in almost all areas of your hospital. And oh, by the way, here's a plug. We have an organization called Biomeds Without Borders. They never have enough electricity in other countries. When you pick up all these unused and unapproved outlet strips, put them in a box and send them to me at Biomeds Without Borders. We'll send them to other countries, and it will alleviate their problem. They're not quite up to the standards of the United States yet, and it's a problem just to get electricity from point A to point B, so everything is of use down there. Here's the resources to buy some of these things, where you can get the long power cords, the twist lock plugs, the ammeters, the line splitters, and the special RPTs, and the websites for them to find them. We are just about ready for questions. This has really been a fairly short presentation simply because I don't think it's such a tough subject. I think it's fairly straightforward. It's fairly easy. I know a lot of you are going to come up with what if, or yes but, or it won't work in my hospital, because I've had that discussion with a lot of people. All I can say is please try it. We initiated it many years ago. It worked like a champ, and it was super, super successful. So try it before you just shut out the idea. If you want a copy of this, there is a copy on the IamTechNation.com/webinars site, or you can get it and all the reference documents that I've referenced in here at the South Carolina Biomedical Association website for the members only section, for which you can join for free. I think we're just about ready for questions.
Okay, Pat, thank you so much for your presentation. We do have a whole list of questions that have been submitted during the presentation, and we'll go ahead and get started with those. The first one we have here is, do you think we need to inventory the power strips and put them in our equipment database with hospital ID numbers?
Absolutely, without a doubt, yes. We can't monitor them, identify them, or check them, or take care of them if we don't have them uniquely identified. Yes.
Okay, thank you. The next question is, do you think we can put them in our PM system as a run to fail, or do we need to do an annual PM on power strips?
I think we definitely need to do at least an annual PM. I would not put them as run to fail simply because that's what we're doing now. We are running them to fail now, and they can fail in ways that are not obvious. The things that you have run to fail tend to be medical devices that, if they fail, some user can identify that it's failed and take appropriate action. There's nothing with the power strip that's going to tell anybody that the ground is bad or something else is going wrong with it. So I would say that this is not a candidate for run to fail.
Okay, the next question we have here is, I thought facility-made extension cords were not allowed. Is this correct? I thought we could only use pre-made extension cords.
Well, I don't know that anybody has, I don't think I've ever seen anything in writing that says who has to make them or where they come from. I will tell you that I've seen some made by facilities that are a whole lot better than what you buy in Walmart or Lowe's. I've also seen some that are that much worse. So I don't know that, I think that the emphasis probably is on properly made extension cords, but the guidelines has always been for short-term or temporary use, which is defined in the life safety code as less than 90 days. So you will find that all hospitals in their emergency cabinets have big 100-foot extension cords. So if they lose power in a room, they have a long enough cord that they can run it down the hall and plug it into an outlet that's still operating. But it shouldn't, no extension cord should be used for more than 90 days.
Okay, our next question concerning the twist lock. Doesn't the twist lock need to be hospital grade if it is going to be used on medical equipment?
No, there is no requirement. It used to be, but there is no requirement that plugs on hospital equipment have to be hospital grade. To put the green dot on the Hubble twist lock or on the Hubble plugs costs you about $5 or $10 more. So for many, many, many years, most people have not been buying the green dot hospital grade plugs, and there is no requirement for that. Now, this new CMS thing says that if you have an RPT, that they need to be hospital grade, but there is no requirement unless there's something in a state requirement that I haven't seen, but there's none that I'm aware of that requires hospital grade.
Okay. This might be similar to what you just touched on, but the question is, why is the green dot hospital grade approved receptacle no longer mentioned in the CMS regulations?
Because they don't require it. They found out that that they are not significantly that much better than a regular high quality outlet. Obviously you shouldn't go out and buy made in China, you know, $1.65 outlet or plug. You ought to buy a decent quality, and I've always preferred the Hubbles myself, but if you get a good quality and good long-term manufacturer, they're going to be just as good.
Great. Okay, the next question we have here is, I'm a third-party biomed company in the hospital. Who pays for the replacement power cords and or purchase of special RPTs? Is it the hospital or the biomed?
No, it has to be the hospital because that's a project. If you're a third party, you're being paid to maintain equipment to fix things as they fail. This is a new and different requirement that is outside the normal maintenance, so it's absolutely nothing that was included in your contract to maintain your equipment. So that's outside your scope of what your company signed up for. So it should be treated as a special project. You should be able to come up with a quote for the hospital for the labor, the materials, etc., to put it together and then have them cut a PO as a special project.
Okay. Instead of the line splitter and the amp clamp to test current draw on special RPTs, couldn't you use the amperage measurement on an electrical safety analyzer?
You know, I think you probably could. That would work just as well. You're right.
Well, thank you, whoever asked that. Okay, next, which are the differences between regular and hospital grade power strips?
I'm not sure I really know.
Okay. Where can I get labels for high current or life support device cords?
I would say have them made at your local shop. Go to your local sign shop. I'm sure that a lot of times your maintenance department in your hospital has sign cutting capabilities. They will have the two-color plastic, and they have a little engraving machine. If they don't have it where they make them in-house, you can certainly go to a local sign shop, and they're about $3 a piece. And you can have, dozens of the same kind made, and you put them on with you can put them with two-sided tape or tie wrap them to the cord.
Okay. Next we have, can you explain daisy chain?
Daisy chain is where you plug one outlet strip into another outlet strip, and you plug those two outlet strips into a third outlet strip. so that you basically have one power cord plugged into the wall, but you've got 6, 12, 18, or 24 different outlets, and they're not intended for all of those devices to go through that first power strip, and it can exceed the current capabilities of that unit.
Okay, next question. How do UPS units play into all of this?
I have not given any thought to that, but off the top of my head, I would think that a UPS unit would be considered the same thing as an electrical outlet on the wall, and I'm not sure that anything would be done any different than they are today with those.
Okay. Next question, can you estimate the dollar cost of this initiative?
I put in one of my things that I think it could be done for less than $50 per bed for the entire hospital. So if you've got a 100-bed hospital, it might be $5,000. I'm not really sure about that. I just pulled that off the top of my head. It depends on the age of your hospital, how many outlets you currently have, how many outlet strips you have, how busy your hospital is, whether you're really equipment intensive, or whether you're a fairly low acuity hospital that doesn't have a lot of high-tech equipment or multiple pieces of equipment on a patient. Depends on how many ICUs you had, all that sort of thing. So it's certainly going to be cheaper than knocking holes in the wall and putting more outlets in every room of the hospital.
Great. We've had a lot of questions today, and I think, Pat, you'll probably follow up with people directly if we don't get to your question during the Q&A. We'll take a few more here. The next one is, how hard has the Joint Commission been hitting this issue during audits?
I'm not hospital-based, so I really don't know. I really don't know how much they've hit that. I don't know if that's one of their focus items. Someone else who's in a hospital would have to address that. I haven't been through a Joint Commission in several years.
Okay, one final question here. What about wire mold for plugging IV pumps in the holding area prior to use?
Absolutely appropriate and absolutely well. One thing we're talking about here is we're referring to patient care equipment as it's being used on patients. Once you're in a holding area, in a charging area, where you're wanting to keep the batteries plugged in and all that sort of thing, you can use anything you want. It doesn't matter, because you're not in a patient care area and you're not putting patients at risk. So putting plug mold or wire mold on the wall to get the outlet density that you need to plug in 50 or 100 infusion pumps, absolutely fine.
Great. Okay, we're going to go ahead and wrap up today's webinar. Like I said, there were lots of questions that were asked today that we simply didn't have time to get to, but GMI will get a copy of all of those questions, and Pat can follow up with you directly on those. I wanted to thank you once again, Pat, for your time today and all the wisdom you shared with us. Again, TechNation would like to thank our sponsor, GMI. Please visit their website, gmi3.com, and that's gmi3.com, to learn more about their products and services. Attendees, please remember that to obtain your certificate of attendance, you must complete the post-webinar survey at the conclusion of today's presentation. The survey will appear immediately on your computer screen. Certificates will be emailed on or before April 1st. If you do not receive the survey, please email us at webinar@mdpublishing.com. Please visit iamtechnation.com/webinars to register for our next webinar Wednesday, which will be on April 22nd and will feature a special roundtable discussion on what's new in biomedical test equipment. And also, hopefully most of you will be attending the upcoming MD Expo, which kicks off this Sunday in Nashville, Tennessee. If you're there, please stop by the registration desk and introduce yourself and wear some of your I Am TechNation gear to support us. We'll have giveaways and lots of great activities for everyone, including education, in which Pat will also be presenting. Thanks, everyone, for participating today, and we look forward to seeing you the next time around.